So hi everyone, my name is Sven Felix and I'm a structural geologist by background, and I'm working here at Eliis as a consultant, as a trainer, as well as a tester, and I'm with you on the support once in a while. So right now I'm going to introduce you the theoretical part of the new things about the automatic fault extraction workflow. So let's get started. So as a brief recap about this workflow that has been implemented since last year, here is what we are doing in PaleoScan. So we're starting first with a seismic, and then with this seismic, we're computing the variance, and we're using a scanning disk in there to compute the best sum of this variance, which is yielding what we name the fault plane attributes, which correspond to a fault probability volume. So this is the step one of this automatic fault extraction workflow. Then in the second step, we are outputting the extrema of this fault plane to generate what we name the fault plane thinning. This is that cube that you see here on the bottom right. And in the last stage, we're extracting the faults, physically, the fault segments, and this is step 3. And out of this, the user can later edit manually these faults to create some fault families, for example, or to merge some faults. So how does it work? So we're starting with the seismic again, as you can see here in line and in variance and in line again, and in time slice as well. So by the way, this example is taken from F03 offshore the Netherlands. So out of this, we're considering the seismic and the variance in terms of voxels, so which are symbolized with this orange gridding in the picture here. And what we're going to do here is for each voxel of the variance, we're going to run the scanning disk, which in reality would be bigger than the one that you displayed here, just for the symbol of it. And we're going to rotate the scanning disk in every possible orientation to get the best sum of the variance. And we're getting to store the maximum best sum at the voxel location in the end. And this is what is going to be the value of the fault plane. So we're going to run this best sum on every voxel of a variance, and we are ending up with the fault plane, which you can see here, and in line with the co-rendering of the seismic and in time slice as well. So we are ending up with this kind of a fault probability volume. And the next stage, as I said before, is to obtain the skeleton of the deformation, which you can see here again with the co-rendering. So out of the thinning that we've captured, we are able to extract physically the faults. So again, you can see in red here, the intersection of the faults that have been extracted automatically out of the workflow. And you can see them in 3D with the fault sticks represented in this picture at the bottom right. So, and eventually, when you're outputting this, you can use the stereonet tool of PaleoScan to conveniently sort your faults in terms of different families, depending on the branch and the object and azimuth that you're interested in. So what's new in PaleoScan 2020? So as for the fault plane, the first step of the workflow, if we're starting from the seismic, we're computing the fault plane attribute. So this is what you got usually from PaleoScan 2019. So now in 2020, we are actually normalizing these outputs to get some clearer fault signature to better capture the faults and to get rid of these sort of vertical gradients of value of the fault plan, so you can better distinguish the faults in the fault plan attributes. So that's a new thing from this 2020 version. As well, in the interface of PaleoScan, you're able to visualize the range of angles for the dip and the azimuths that you want to cover. So for example, here you have this green display in this screen here that correspond to a range of dip in between 70 and 84 degrees. So you're able to better anticipate what you want to capture in terms of fault dip. Same applies for the azimuths in time slice in this viewer here. So as for the fault thinning, which is the second step. So in 2019, this is the kind of output that you could get. And now with the fault normalization that we've implemented, we again see more synthetic results of the faults. On top of this, we've tried to improve our algorithm to have more continuous fault signal in this skeleton of the deformation, and this way to extract better faults. And at last, for the third step of this workflow, the fault extraction, then we've tried to improve our algorithm to enhance the fault continuity. It means that if you got some faults with a good continuity and that they're neighboring, then PaleoScan automatically link some of the segments of the faults. So that's to save some time for the manual addition, so that avoid the users from having to merge manually some of the segments. So you can see here again the differences. So this is what we're doing in 2019, and what's been circled in yellow here are fault segments that have been merged together. And you can see the difference of number of faults here, for example, and the difference with the 2019 version, which is listed on the top. So we have, for example, here 618 faults, whereas in the new version, we're saving some fault segments that have been automatically merged, and we're down to 524 faults. So with this, I'm going to leave you for the demo, for the practical thing with Jean-Philippe Adam, and I'm coming back later for the multi-Z model.
Thanks, Sven. Okay, as Sven explained, I will present you this new feature in live demo. I will just share my screen. Okay, my application. Okay. Okay, now, okay, I will. This is PaleoScan 2020. As you can see, we don't change a lot of things in terms of interface. But we have implemented a lot of tools, and especially, as Sven explained, for the automatic fault extraction. First of all, for this presentation, I will use this dataset. It's XMOOS dataset. It's Australian dataset. And as you can see, I will just navigate very quickly. We have very huge area of fault extraction. And I will show you the difference between the two extractions between the PaleoScan 2019 and 2020. Okay, first of all, concerning the fault extraction, okay, under volume, you still have attributes, and then you still have the automatic selection for the automatic extraction workflow. For the one who already used this tool, we still have the same workflow in 3 steps that then Sven presented you during the PowerPoint, and I will show you the full workflow from the seismic and to create the fault plane and then all the different outputs. Okay, first of all, just in terms of interactivity and interface, we add in the attributes windows some information concerning some attributes because we have it's a complex computation. Due to this, we have different parameters. Now you have more and more control on these attributes, and we have just indicate some information for the extraction. Okay, just drag and drop my seismic. And so, first of all, just for the interactivity, we add a stereonet for the deep azimuth filter. Like this, you can really see directly. Okay, I will just navigate. Okay, you can see directly the range of deep and azimuth you extract in inline. Also, if you just go under time slice, it's exactly the same like this. If you have a fault direction, a major fault direction, and you want only to extract this fault, it's really easy to set. It's more easier to set up because, of course, okay, we extract from seismic, but if you want just to choose your parameter, you can drop the variance, for example, to have better display of your fault plane and choose your orientation, and then you just have to, just before the computations, to drag and drop your seismic. Also, yeah, concerning, I will just compute a preview. Concerning the parameter and the new thing we implement, as Sven explained, for the fault plane, we implement a normalization of the workflow to have a clean preview and clean view of this fault plane. Okay, take just a few seconds to display the preview. And PaleoScan, yeah, will normalize this previous attribute. Just a few seconds. And like this, we will have this kind of result, much more cleaner compared to the previous one. I will present you just after. Also, just for the new parameter, we have a scanning disk weighting. In fact, on the previous method, it was already the Gaussian function. In fact, depending the distance from the center of the pixel, we apply a Gaussian weighting ponderation of each value of the disk. If you want to speed up the process, now you can use the flat option like this. All the points of the disk will have the same weight. Okay, we don't apply this Gaussian filter and for the ponderation. Like this, we speed up the process. Also, yeah, just for the thinning, we have two different methods, Gaussian or Hessian. These two options, it's more not again under the bubble information. It will be under the user guide. Depending the kind of fault you want to extract, regional fault or more local fault with more detail, these two options will give you more information depending the kind of environment you want to extract. And as Sven explained, when you extract some fault, we have auto merge option like this to speed up the process and to avoid to merge a lot of fault. Okay, if I just come back and open a blending viewer, okay, I will just open my seismic, and I want to compare the result between 2019 and 2018. Okay, if I just drag and drop, this was the previous release. As you can see, it's already good. If I just have a look in time slice, okay, it's very good. But thanks to the normalization, we have something who delimitate much more better the fault, and it will be easier to extract the fault, especially for the skeleton, the fault thinning. If I just drag and drop the previous one, thanks to the previous method, okay, we can delimitate clearly the fault, but we have a lot of noise. Thanks to this normalization, we have something much more synthetic, as Sven explained, and allow us to extract more fault and more to be more precise. If I just, okay, I will just close and open just my seismic, just for the conclusion and on the automatic fault extraction. If I drag and drop the fault extract with 2019 release, okay, all these faults were extracted with the previous algorithm. As you can see, we have already many faults, okay? But for example, if I have a look on this one also, PaleoScan divide in different parts the fault. Now, thanks to the new algorithm, I will just select the fault just to put the previous fault in red. This is the result with the new release. First thing you can see, we have much more faults compared to the previous release. And second one, if I just, if I just toggle off, for example, you see for this big fault, okay, I showed you just before, PaleoScan, okay, I still have one or two faults, but I have less fault compared to the previous release. Like this, you will speed up the process of fault refining, fault merging, and this kind of thing. And as you can see for this example, we reduce the number of faults around 100, a little bit than less than 100 faults, but okay, automatically PaleoScan merge many faults to reduce the number of faults by 100. Okay, this is the new feature for the automatic fault extraction. Just concerning the structural framework of PaleoScan and the new feature of PaleoScan 2020, a small tool, and Steve Tobias will present you in a case this new feature. We have a new option. It's called seismic ghost. We have a little ghost icon just in this part, and thanks to this tool, you just have to draw your polygon, and then you can move to check correlation across a fault, and like this to find connection across the fault. And you can use this tool on all the different viewers of PaleoScan. And for example, during your seismic interpretation and your model grid refinement, you can use and merge your horizon thanks to this tool. Exactly as all the tools of PaleoScan, if you click and you go under property, we have different parameters. You can change the transparency, okay, of this ghost, or you can display a correlation value just to find the best correlation between both parts of the fault. I finished with the presentation of the automatic fault extraction and with the ghost as bonus at the end of the presentation. I let Sven-Philippe present you the new feature concerning relative geological time model. Thanks, and see you for the next presentation.